Alright, so for this specific example, we're going to be using some 0.5 NaOH that we just got off the shelf. Normally you're not going to be standardizing things that come off the shelf because we already know what they are when they were made originally, but solutions like this can kind of dilute themselves just based on time. This solution was made 15 years ago, so this one probably isn't actually going to be 0.5, it's probably going to be a little more dilute than that, but we'll test that out. A lot of the time when you're standardizing something, it's going to be something that you've made specifically or maybe another TA has made, and you want to make sure that it's very precise, because if we use the scales out in the classroom, we can get a molarity up to 3 decimal places. So we can get a very precise molarity for when the students are going to be doing a titration, or maybe if you're doing a titration for something that isn't a lab, you could do that as well. So we've set the KHP solution with the phenolphthalein under the burette. We're going to make sure that we slowly drop the thing in drop by drop, the NaOH. And then once it turns a light pink shade that persists, we're going to stop dropping, and we're going to be able to make sure that we know how much we used and calculate the moles from there. So here we are, we're just stirring as we keep going. We're going to make sure that this process, every time we're stirring, the pink completely goes away. If it begins to persist, that's when we know. So we'll time lapse this so it's not really boring. You'll notice that we see that the pink persists for a little longer the more NaOH we add. This is because it's getting closer and closer to the equilibrium point at a pH of 7, that is. So you can see longer and longer each time. So as we can see here, we actually went a little past the equilibrium point. I probably should have stopped 1 or 2 drops sooner. So it's not the best test, so be a little more careful when you're getting close. But it's not too bad. I mean, worst comes to worst, it's probably like, maybe 2.2 milliliters off, so it's really not that bad. But as we can see, we have a dark pink here. We would have liked to see a white pink, or a light pink, like as we reflect it through onto this white note card or white piece of paper, whatever you're using, but we'll do with what we've got. So we started with the thing at the 43.2 mark. We got it all the way down, let's say 44.3, or 48.3, 48.43. So there we're going to be able to calculate the difference in the 2 molarities that we had, so we'll just plug those in. So in this this test here, we required about 5.22 milliliters worth of NaOH to neutralize the KHP. So if we go and we calculate what that's going to be, we have the moles of NaOH that were needed to neutralize this KHP, and we also have the volume of the NaOH that we ended up using. So with that, we obviously can just divide moles by liter to get molarity. So I'm going to take this value from up here, and we're going to divide it by the difference. But we need to make sure that we're working in liters here, so we're going to convert that down. And it comes out that this NaOH is going to come out to 0.45 molarity. If we would use the scales out in the classroom, we would see that we would be able to get to 3 decimal places, but for this one, we're only working with 2, but still 0.45. Now we're going to be able to more accurately label this. when we put it in the hood for the students to use, or we fill their burettes. Oftentimes they'll standardize their own anyway, but we like to know what it is anyway. So yeah, there was a demo of how to do standardizations.